Okay, welcome back to the ASHSPEC PCB manufacturing. This is the artwork for the power management module for the dashboard system. You can see red traces which represent the copper that's on the top side of the board, and all of the green artifacts are on the back side of the board. So that's the program that creates the layouts that I put those together. So what we're trying to do is take it from that into something that we can load into the laser control. So the final section of code that I just completed is in the PCB tool is to create the laser path. So there's a few options in here, obviously. Obviously selecting whether we're going to be doing the top board, the top layer, or the bottom layer. And you have some orientation presets. I put some options in here for mirroring based off of the board drawing file, which may or may not be useful down the road for other applications. But for this one, I don't need to do it that way because I'm doing just standard face-up physical view as if you were looking down on the top board or looking down on the back side. This geometry configuration here, what this is going to do is it's going to expand or contract from the original artwork because when the laser cuts the mask that's on the board and you put it into etching solution, the etching solution will tend to kind of undercut the tape a little bit. So you end up with traces and pads that are smaller than they would be in the drawing originally. So this gives you the ability to expand I put contraction in there, even though you wouldn't probably normally use that, but you can go either way. The laser kerf width, this is the actual specification for how much width and height does the laser beam itself take up. And this allows you to add to that. You can make it all up just in this offset, the expansion here, or you can specify it separately. For what I'm producing right now, I'm just showing it based off of a replication of the original board definition file. As far as for cutting circles, your arc segments for quadrant, rather than drawing true arcs, I'm basically breaking it up into a series of polygons. So in this particular setting, this is the default. It's 16 polygons per 90 degrees through an arc. It was just easier to program it that way rather than actually using true arc functions, because there could be some funny stuff that goes on whenever you draw a circle that has a straight line coming off of it. So I chose to do it that way. Simplification tolerance is basically a parameter that allows you to make your circles not so complex, basically. It is tied in with your arc segments per quadrant. But other main configurations, the actual cutting speed, the travel feed, when it goes from one island to another, your laser power, the type of laser command you're using. They have dynamic power for like when it goes around radiuses. Your total XY travel is not quite the same as traveling in a straight line. So that's dynamic power, or you can just do a constant power M3 command. These are options that are controlling how it generates the G-code file that runs the laser, and any delays. And then this is just basically a preview of how many objects on this particular board. 231 copper objects, 91 merged copper regions. Getting through though to saving the laser G-code. I'm going to skip that one step simply because I've already done that. And the program I'm using is Laser GRBL, and you can see a nice beautiful toolpath right there. So these lines are actually what the laser beam will follow, and well, heck, we can even just run that too. And there it goes, cruising right along. It's at about 400 millimeters per minute. With 20% laser power, which is what I found to be just perfect for cutting through this blue painter's tape. That will result in a board with cuttings that you can peel away, weed it out, and you're left with a board that's got a nice mask on it, ready to go into an etching solution, which will dissolve away the exposed copper and leave only the circuit traces behind. So that's that.